Hello, 8th grade math students. We are still working on chapter 2B. We're working into 2.7 guided notes today. Make sure that you're putting your name at the top of your paper. That way you receive credit for your work that you are completing. So we're still working with proportions this week, ratios, proportions, all those fun stuff, and making algebra equations out of them, okay? This week we're also working with similar figures, okay? Similar figures. This is a similar sign that is mentioned here. You can kind of see it right there. Similar figures are figures that are roughly the same size, similar in proportions and values, okay? So we can solve for missing parts of them if we have two different figures that are similar. So that's what we're exactly going to do for this first one. We're finding the value of x in this diagram. For triangle ABC, I have 8 and 10, so I'm going to write that as 8 over 10. I'm going to set that equal since they're similar. 2, I'm going to match the sides up. My x has to go with the 8, and my 4 has to go with the 10, as that is the same size. I'm going to cross multiply just like I've been doing with my other problems. 10 times x is going to be 10 times x still. 8 times 4 I know gives me 32. I just now have to divide, undo this multiplication. So I'm going to divide each side by 10. These cancel out. I'm left with x equals 32 divided by 10 gives me 3.2. Or I just move my decimal place over one spot since I'm dividing by 10. Just to show you guys, 32 divided by 10 gives me 3.2. If we go down to the second problem, working with totem poles and shadows. A totem pole casts a shadow 30 feet long at the same time that a 4-foot child casts a shadow that is 3 feet long. Write and solve a proportion to find the height of the totem pole. So I don't know what this one is here, so that's my height of the totem pole. So we're going to use h in this situation. Some of it as h over 30 is set equal to 4 over 3, the child's height and shadow. Again, I'm just going to cross multiply. 4 times 30 gives me 120. H times 3 is just going to give me 3h. All I have to do now is undo my multiplication by dividing. Divide each side by 3. Those cancel out. 120 divided by 3 gives me 40 equals h. Just to show you again. And I need to make sure that I have a label there, so I'm making sure that I'm writing it. It's 40 feet tall. And there's my answer. If you flip the page to example number 3 on the backside, we're working with similar rectangles. We have a 6 by 8 inch rectangle and a 15 by 20 inch rectangle. And they've been multiplied by 2.5 to form similar shapes. Okay? Just to show everyone, if I have 6 times 2.5, I get 15. So that's why these are connected. If I do 8 times 2.5, I get 20. So they're similar. They asked me, how is the perimeters related to the ratio of the corresponding sides? So let's find out and solve for the perimeters first. So I can do, my perimeter is length 1 plus length 2 plus width 1 plus width 2. Or 2L plus 2W equals perimeter. So if I plug in everything from my top one here, 2 times 6 plus 2 times 8. When I solve for both of those, I have 12 plus 16, which gives me a total of 28 inches. That's from my 6 by 8 inch triangle or rectangle. Now if I solve the same problem for my larger one, that's what we need to do here. 2 times 15 plus 2 times 20. I end up with 30 plus 40, which equals 70 inches. Again, I just want to solve 6 divided by 8 to find out what the ratio is, or 6 divided by 15 to find out what the ratio is there. If I do 6 divided by 15, I can see that my ratio is 0.4. I want to double check that to make sure that's the same for my 8 over 20. It's also 0.4. 0 there first. Now what I need to do is set to see if this ratio between my perimeter of my smaller rectangle and my larger rectangle are the same. So I'm going to do 28 divided by 70. Seeing if the ratio is the same. It is the same. So I can say that the perimeters and I know that the perimeters are related to the ratio of the corresponding sides as they are the same. So they're all the same. Perimeters and sides are all the same. Now it asks us, how is the ratio of the areas related to the ratio of the corresponding sides? So I already have my ratio of my corresponding sides right here. I just need to solve for my area. Remember my area formula equals length times width. So I'm just going to do 6 times 8 for my top one, which gives me 48 inches squared. That's for a small rectangle, my 6 by 8 rectangle. And I'm going to do my 15 by 20 rectangle. I'm going to do 15 times 20. I end up with 300 inches squared. I'm going to set these proportionally to each other just like I do with those. So let's try it. 48 divided by 300. Am I going to get 0.4 again? Or am I going to get something different? I end up with something different. So these, my corresponding sides in my area are not the same. Ratio does not equal the ratio of the areas. That's my answer for my second one right here. Because these are not the same. My 0.4s are not the same as 0.16. Make sure you're completing the summary down here and putting it in your own words of how you can solve a proportion. When you're finished with that, make sure you're working on the homework or the practice problems, okay? The practice problems for this week, or for today, include 5 different ones. You're setting it up, solving for the missing value in each of these problems. These are all similar figures. You'll see that there's the similar sign right here. So you can set them up as ratios. Okay. You also have a shadow problem with a utility worker and a utility pole. I even gave you the pictures so that way you can set it up and label everything nicely and neatly as well. Make sure that's finished and then put it back in your red folder for next time that we meet. Thanks, guys.